Okay, everybody, let's finish up lecture 12. So we're starting the next chapter, chapter 11, which is all about stars other than our sun. So we'll start by talking about an astronomer named James B. Kaler, and he taught at University of Illinois, and he made some very important discoveries. So for most of human history, people just assumed that stars were eternal, not really realizing that they have life cycles just like we do. They're born, they live through their lifetime, and then they die. So James Kaler was important in that because he discovered a binary star system that had gone crazy. So one of the things that's hard about figuring out stellar evolution or what are their lifetimes like, is that you can't watch one for long enough, right? You can't watch it be born, watch it live through its life, and watch it die because these time scales are much, much longer than a human life. So people were a little skeptical about stellar evolution, and Kaler really had a great discovery when he found a symbiotic binary system, which he could actually see changing in real time. And that was a sort of a big clue into people that stars could change. They weren't eternal. Okay, so to understand how stars evolve, astronomers have to find links between properties that they can measure. And we're going to spend a lot of time in chapter 11 talking about what we can measure and how we measure it. What are the properties we can measure about stars? And then you have to put all that together into a story about how stars live and die. Okay, so just to give you a little bit of background on this symbiotic binary system, a symbiotic binary system is a system where stars are so close to each other they actually exchange mass. So one is pulling mass off the other, and that causes them to change brightness in very short time scales in regular ways. Okay, so again, people once assumed that stars were eternal, but stars have lifetimes just like we do. And a lot of what we're going to talk about in the next few lectures is how we measure all the properties we need to measure to figure out their life cycles, and how they're born and how they die. So we're going to spend a bunch of time on all of that. Why don't we try a question? Oh, going the wrong way. Pause your video.